Okay, so today let's talk about the section 7.6, graphs of the sine and the cosine functions. Okay, so we know that we already defined the sine and cosine and the tangent, cotangent, secant, cosecant for arbitrary numbers. Remember that you have a unit circle. This is a 1, and you draw the vertical line through the 1, and whenever you have a t, this length is t, you wrap it around the unit circle, you get the corresponding point P. The P has coordinate A and B, then the sine t is B, cosine t is A, and then from AB you can get the other 4 trigonometric functions. Okay, so in this process, just remember this circle is a unit circle. It has a radius 1, centered at the origin. Okay, so now we have 6 trigonometric functions. Now let's just let's use x, not t, x. We just discuss first two. We want to see the graph. Whenever we have a function, you can define. You can discuss the graph of the function. Okay. So the graph means you have a point P, then you have x and fx point coordinate. You have sine. You have x and y. Now, it means okay. We're going to first get several sample point, several special point. So with experience, we will have this point. Why we first label this point pi 0? 0 means when t is here, pi over 2, it corresponds to the intersection of a unit circle with a y-axis top point. Pi is this left point. 3 pi over 2 is the bottom point. 2 pi is back to 0. Okay? So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So these 4 points are the 4 special points on the unit circle. And from 0 to pi over 2, it means this point. Okay? From 0 to pi over 2, this is the first quadrant. From pi over 2 to pi, it's a second quadrant. This interval gives us the second quadrant, the angle in the second quadrant. And pi to 3 pi over 2, this is a third quadrant. 3 pi over 2 to pi is a fourth quadrant. Okay? And then you're going to recall that table. Remember that we have some table. Sine 0, 0, sine pi over 6 is 1/2, sine pi over 4 is the square root of 2 over 2, sine pi over 3 is square root of 3 over 2, sine pi over 2 is 1. So sine pi over 2 is 1. And also we know that the sine function is between -1 and +1. So you don't need a lot of a y-coordinate. You just need the y-coordinate between -1 and +1. Sine pi over 2 is 1. And if you carefully label the points and continue this estimation, the evaluation, and you do the plot point by point, you will see the graph is more or less like this. It's up, reached 1, and down to 0, and then down to -1, and back to 0. Okay, so this is just a plot of the sample point we have known. So you just go here. Okay, so this is a graph of sine function. We say in one period. Remember, the sine function is periodic. Sine of x plus 2 pi is sine of x. So when you have other point, it is a repeat behavior of the interval 0 2 pi. So if you continue this, you will get another one, another period, and it's continue. It's infinite graph. The graph is from negative infinity to positive infinity. If you continue this to the left, it's like this. It's a wave function. We call it a wave function. It's up, down, up and down, up and down. Okay. Okay, so this is the graph of sine function. We cannot carefully plot point because most of the sine values are irrational values. So it's not that simple to precisely label the point. You should get the idea and use a computer to graph it. And this point, we check some special point. This point, the x coordinate is pi over 2. The y coordinate is 1. The 1 comes from sine of pi over 2 is equal to 1. And this is a pi 0. This point is 3 pi over 2 and the negative 1. Negative 1 is a sine 3 pi over 2 equal to negative 1. Okay, sine 2 pi is 0. Okay, so that's the special values. Here is 0, 0. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi, 0. And then you repeat. And from here you will see that whenever you have multiples of pi, this is 0, pi, 2 pi, and here will be 3 pi. Here's negative pi. So sine of k pi is always 0. Sine of k pi is always 0. Sine 0, 1 copy pi, 2 copy pi, 3 copy pi, 4 copy pi, 5 copy pi. Whatever integer multiples either positive or negative, sine of k pi is always 0. Okay, and actually we can have more. You see here you have pi 0 plus pi over 2, you get 1. So 2 pi plus pi over 2, you get 1. So if you want, you can collect more information, but so far this is enough for our next computation. Okay, so that's the simplest function, y equal to sine of x. And sometimes we have some numbers associated with y equal to sine of x. So for example, we have the function y equal to 3 times sine of x. It has a coefficient of 3. So how do we sketch the graph it? Okay, we try to graph 3 times sine x. So how do we graph 3 times sine x? We'll have the following strategy. So first, we sketch the graph of a sine. Well, this curve is a little bit flat because you see here, this is 1 pi over 2. Pi is 3.14 more or less. Pi over 2 is 1.7 stuff. So this number is much bigger than 1. Okay, it's bigger. Bigger than 1.5. So this number is bigger than 1. So it's a flat. It's more flat. You cannot draw it very large, very high. Okay, and then when you multiply it by 3, technically you just change this 1 to 3. So you stretch it along the y coordinate. So originally 1, 2, originally it's 1, now you need 3, so pi over 2. So you're going to lift this point to 3. So it's like this. Here 3, here's negative 1, 2, 3, negative 3. So pi over 2, pi, 3 pi over 2, 2 pi. Okay? So you don't change the basic shape, you just stretch it along the y direction. So you get 3 sine x, 3 sine x. So this coefficient of 3 will change the y. Okay, so that's the process. You stretch it along the y direction. Okay. And second, we let y equal to negative sine 2x and graph it. Okay, so we're going to have some similar process. Step 1, we sketch the standard sine function. Okay, standard sine function. This is pi. This is a pi over 2. About 1.5, 1.5, not 1.7. Stupid. And this is 1. This is negative 1. Standard sine function. And you see here, this place you have a negative sign. Whenever you see a negative sign as a coefficient, you flip the graph up and down. You make this top to the bottom, bottom to the top, because of this negative sign. Okay, and this is the same point. After that, what's next? You see, our x is 2 pi. We finish this period. Now you have 2x. It means when x is pi, you can reach this 2 pi. I want this internal stuff equal to 2 pi, not just x. I want the sine of 2 pi. So when x is pi, you will get the sine of 2 pi. So you don't need x to be 2 pi. You only need x to be pi. You finish this one period. Okay? So what we're going to do is that whenever you have a coefficient 2 here, you kind of squeeze this graph from 0 to pi to 0 pi, because it's coefficient 2. The coefficient 2 already make it big enough. So you see, when x is pi, you get sine 2 pi. When x is pi half, you get sine pi, right? So we don't really care at this moment. We don't really care the x. We care the behavior of the total thing. 2x. 2x is 2 pi. 2x is pi. 2x is 3 pi over 2. So this is the graph of y equal to negative sine of 2x. This is one period. When you have one period, you just continue this, you will get the other period. Here is from 0 to pi, so this is from pi to 2 pi. One period, this moment, has a length 0 to pi. The length is pi, so the next period is also has length pi. Right? And to the left and to the right. Okay? This is a sine function. Sine function, we know how to sketch the graph. We know how to multiply with some coefficient. Here you see the difference. This coefficient is outside. When you have the coefficient outside of sine, you stretch it along the y direction. If you have a coefficient inside of the sine, you stretch it around, along the x direction, because this 2 affects x before sine. This 3 affects the value after sine. So after you get the shape, you stretch it along the y direction. Before you get the shape, you stretch x. Okay? So that's the property. Okay, so that's a sine function. After you get sine function, let's check the cosine function. Cosine function, we just do the similar process like sine. We plot the point. Cosine 0 is 1. First of all, cosine. We also know that cosine is between -1 and +1, so it's also just between these 2 points. And the cosine is a periodic function. So we only need the graph between 0 and 2 pi, and then repeat it. And let's see, cosine 0 is 1, and cosine pi over 2 is 0. So this is 0. And if you label them, it will be like this. And like this, like a butterfly stuff. So this is 2 pi. This is a 3 pi over 2. This is pi. It's a pi over 2. At pi is -1. Okay, so this is cosine. The graph of cosine. It's like a bird wing, a bird with a open wing. And if you want to repeat it, and here the similar thing. Okay, so this is another wave function. Another wave function. And you will see that they intersect here, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, all the powers of pi over 2. Or in other words, what are those points? They are always 0 plus pi over 2, pi plus pi over 2, 2 pi plus pi over 2. So cosine, all the k pi plus pi over 2 is equal to 0. See? All the k pi, an integer pi plus pi over 2, an integer pi plus pi over 2, an integer pi plus pi over 2. All the integer pi plus pi over 2, cosine value is 0. Okay? Okay, so this is a graph. This is a standard graph, y equal to cosine of x. And remember, cosine x is an even function, so that's why it's also clear. It's a symmetric about the y coordinate. Oh, y-axis about the y-axis. It's symmetric about the y-axis. It's even. Even function. And if we shift this graph, we just do some observation before we can really do some computation. If we shift this graph pi over 2 to the right, like you move this to the right, you move it to here. Let's copy. You move this point to this point, to parallel, shift it. If we shift it, see, this point to this point, here to here, and here to here. Shift it pi over 2, so we get this graph. This graph is exactly the sine. You shift the graph to the right, you get cosine x minus pi over 2 to the right. pi over 2. So cosine x minus pi over 2. And you get exactly the graph of a sine. So we guess cosine x minus pi over 2 is equal to sine x. And later we will prove this is the right one, but so far we just get the formula based on the observation. Okay, so we shifted the graph to the right, pi over 2 unit. Shift it to the right. Shift the graph to the right, a unit is fx minus a. Shift the graph to left, b unit is fx plus b. Okay, so you just manipulate x coordinate. Manipulate x to the right minus a, to the left plus b. Okay, so that's the relation based on our observation. We will see why it is later. Okay. Remember that when we have after we have the sine, we tried to discuss the graph of like a sine and with what is the x next? Okay, omega x. We know how to graph this type of function. Okay, and in this type of a function, we call absolute value of a. A can be positive, can be negative. When a is positive, you just stretch it along the y-coordinate. When a is negative, you have to flip the graph. Remember that? So this absolute value of a, we only talk about the positive part. The absolute value of a is called the amplitude. Of y equal to a sine omega x. Absolute value A is called the amplitude, and the quantity 2 pi over omega is called the period of y equal to a sine omega x. Why? It's because you see here, we care sine 2 pi. In order to get a sine 2 pi, it is omega. You see, we have omega 2 pi over omega. 2 pi is a period of a sine. So we want 2 pi. But in this formula, x has a coefficient omega. So it's omega times the corresponding value for x. It is 2 pi over omega. And then this gives you the period. Okay? So for the function a sine omega x, it has two quantities or two concepts. One is called the amplitude. The other one is called the period. The amplitude is used to determine the maximum and minimum value. Here, let's just assume a is positive. So amplitude give you the highest and the lowest point. Period give you the most right point from one period. Okay, so this is omega 2 pi over omega. Okay, so that's the concept. One is called amplitude, the other one is the period of the new function. And for example, if we have y equal to 3 sine 4x, 3 times sine 4x, then amplitude it is up's value of 3, which is 3. The period is 2 pi over 4. Remember, this is a division. 2 pi over the coefficient. 2 pi over 4 is pi over 2. 2 pi over 4. Okay, so this is a period, which means the graph will repeat every pi over 2 unit. Every pi over 2 unit, the graph will repeat once. Okay. Okay, so that's the amplitude and the period. And in this graph, let's check it. This is a standard shape. Whenever you have a sine function, it will be like this. So you need 1, 2, 3. 1, 2, 3, 4, 5. You need those 5 points to determine the regular shape. Whenever you have these 5 points, you can just trace them and get the graph. So these 5 points are called the key points. Key points. So we can use key points to graph the sine function or cosine function. Okay, so let's check it. Let's check it. The key point, use key point to graph y equal to 3 sine 4x. Y equal to 3 sine 4x. So first, you know that the amplitude is equal to 3. The period, based on what we just discussed, is 2 pi over 4 is pi over 2. Okay, so 3 negative 3. Pi over 2 is 1 period. Pi over 2 is 1.5. It's very small. Wow, it's bad. So 1. Let's assume this is pi over 2. Okay, check here. We need to divide it once and divide it twice. So we need 4 subintervals. 4 subintervals. This is pi over 4, half of it. And this is pi over 8. It's 3 pi over 8. Okay. And then we are going to evaluate pi over 8, pi over 4, and 3 pi over 8, and pi over 2. Okay, so you and 0, of course. So you find the 0. So 4 times 0, 0, sine 0, 0. So you get the 0. So you have a point 0, 0. You get pi over 8. 4 times pi over 8 is 1/2. Pi over 2. Sine pi over 2 is 1, so it's 0, 3. And you continue this. Pi over 4. It's a product. Remember, this is sine 4x. It's 4 times it. It's 0, 0. And 3 sine 4 times 3 pi over 8. It's 3 pi over 2. Sine 3 pi over 2 is negative 1. And 4 times pi over 2 is sine 2 pi, sine 2 pi 0. Okay, so you get 0, 0 here, and 0, 3 here, and 0, 0 here, and 0, negative 3 here, and 0, 0 here. So you just smoothly connected them. Okay, so this is a using key point to graph the sine function, because the sine function is always like this. You just connect them smoothly between those 5 points. Right? So we don't, if you know how to use a key point to graph it, so we will not start from the standard graph and stretch it along the y direction, squeeze or stretch along the x direction. Use those step to idea the graph. We just use the key point, 5 point. Use a 5 point, because the shape is always up and down, like this. Okay. Let's see another example about this graph. Okay. Graph y equal to 2 times sine negative pi over 2 x using key point. Okay. So first, sine negative pi over 2 times x. We know that sine is an odd function. Remember that sine negative x is negative sine of x. So this function, before we do any computation, let's move this negative sign forward. Okay, and then we know that the amplitude is equal to up's value of negative 2 here. This is the a. Up's value of it is 2. The period is 2 pi over whatever the coefficient is equal to 4. It's a division, so 2 pi over the coefficient, 2 pi over pi 2 is equal to 4. Okay, 1, 2, so it's a 2, 4. Here's 2. Here's negative 2. Okay, so that's the setting. And 4 is period, so this is a half a period and a quarter period. So first quadrant, second quadrant, third quadrant, fourth quadrant. Remember that these 4 quarter parts correspond to first, second, third, fourth quadrants. Okay, then you will have 0, 1, 2, 3, 4. You evaluate the function at 0, 1, 2, 3, 4. You check the value. When you get 0, it's 0. When you get 1, it is sine pi over 2. So let's just do one evaluation. We choose 1 here. When you get 1, pi over 2 times 1 is pi over 2. Sine pi over 2 is 1, so it's negative 2. Be careful. Here you have a negative sign. You more or less you're going to flip the graph. So it's negative 2 is here. And this part, this part, this part. You just do the evaluation, 5 times evaluation. You will get the graph. It's like this. So compare with the first example we had. When you have a positive coefficient, it's up and down. Up, down. When you have a negative coefficient, it's down, up. That's the regular pattern. Okay? The positive coefficient is up and down. The negative coefficient is down and up. Okay? So just try to evaluate at those 4 points. And we only sketch one graph, one period. That's enough. You don't have to graph more, because if you want to get more, just copy it. Just copy it with the same graph. Okay, now let's see another more complex formula, functions. So we graph y equal to -4 cosine pi x minus 2 using key points. So this time we have additional part -2. Okay, so when you have amplitude, you have a period part. It's okay. We just have the regular part. We had some examples. But when you have -2 or +2, you should be a little bit careful. If you use -2, -2 means you're going to lower your total graph 2 unit, lower it. So your baseline, remember, check here. This is a baseline. The line through this graph, this is baseline. Without that -2, the baseline is a x-axis. If here you have a -2, the baseline is y equal to -2. If you +2, of course, the baseline is moved upward. Here you move it downward because it's a subtraction. Okay, so first you have this, and then you use those amplitude period idea to sketch it. So first amplitude. We only discuss amplitude for the sine. Cosine is the same thing. Amplitude is ups value of a. A is -4, so its ups value of -4 is equal to 4. The period is 2 pi over omega. Omega is this pi, so it's 2 pi over pi is 2. So you also have 2 here. So this gives you 1 period. 1 period is 2. Half is 1. Here's 1/2. Here's 3 halves. So it's the first, second, third, fourth quadrant. Okay, so you have the corresponding part. Okay, and next we have the period is 4. 4 means you start from the base point. You get 1, 2, 3, 4. It's a huge. Okay, it's here. So this number, this 4 is used to measure the top point and the low point. So 4 means you start from this point, from the baseline, 1, 2, 3, 4, 4 unit, or go down 1, 2, 3, 4. Unfortunately, sorry, yeah, 4 unit here, and then you try to use the key point 0, 1/2, 1, 3 halves, 2. So you get y equal to -4 cosine. Let's do the computation. Times 0. We evaluate. We evaluate at those 5 points. So at 0, pi times 0 is 0, cosine 0 is 1, so it's -4. -2. -2, -6. Okay, so it is -6. This is 3 -4, and 5 -6. It's here. It's here. And y is 1/2 cosine. Pi times 1/2. cosine pi times 1/2 is 0. Cosine pi half is 0. Cosine pi half is 0, minus 2. So it's 0 minus 2 is negative 2. It's here. And you continue this pi times 1 and minus 2. So cosine pi is negative 1. So it's 4 minus 2 is 2. It's here. So if you continue this, you will see it is like this. And up. And down. Very, very thin because the 4 is too big and the 2 is too small. Okay? So that's the graph of this. Okay, so you if you want, we can finish all 5 evaluations. Pi times 3/2 minus 2. Cosine 3/2 is 0, minus 2 is negative 2. So that's why you get this negative 2 back. And then when you get y equal to negative 4 cosine pi times 2, cosine 2 pi is negative 1. Cosine 2 pi is positive 1, sorry. Cosine 2 pi is a positive 1, so this negative 4 minus 2 is negative 6. Okay, so that's why it is back here. You have negative 4, so you flip the positive 1 to be the negative 4. Okay, so this problem is more complex because this problem changes the baseline. Minus 2, you lower the baseline 2 unit. Plus 2, you will, of course, if you have a plus 2, you will lift the baseline 2 unit. Okay, so that's the more complex examples. Okay, so next, we have an equation, we have a function, we can find the graph. If we have a graph, we can also determine the function. So find an equation for the following graph. Okay. So it's 1/2 quarter, 3 quarters. So it's 3. This is 0.3. Negative 3. Okay. Let's see. First of all, you have to determine, is this a sine graph or cosine graph? Sine graph starts from 0. Cosine graph starts from the top point. So here it starts from top point. It is a cosine. And it's starts from top. Okay, let's see this. If you have this way, it's a sine. If you have this way, this is a negative sign. If you have this way, this is cosine. If you have this way, it's negative cosine. Okay, so that's the 4 pattern, four graphs. Okay, here we check this is cosine. And the highest point give us the amplitude. So y is here 3, so amplitude is 3. No negative sign, so 3 cosine. And period is 2 pi over omega. This place is equal to 1. The period is 1, so 2 pi over omega is 1, then omega is 2 pi. So this is 2 pi x. That's it. It's 2 pi x. Okay. So keep these graphs, these 4 graphs in mind. You will easily or very, very quickly determine the function. Right? We're going to use this again to find another example, to solve another example. Okay, so let's check what happens if we have the graph like this. Okay, you see, this shape is negative sign. Another way to check it is the following. This part, you see the first, either bottom point or the top point. You see the first bottom point, -2. So y is -2. This part, you see the first top point is 3. So y is 3 stuff. The first, either maximum value or the minimum value. If you see first maximum value, it's a positive. If you see the first minimum value, it's negative. It's always this way. You see, you have, this is a minimum, negative. It's a minimum, negative, except 0. 0 is a 0. Give us a difference about sine, cosine. Start from 0, sine. Start from different value, it's cosine. And you see that first you see the maximum value is a positive. First you see the negative value, minimum value is negative. You see the positive value, positive. You see the negative value, negative. It's the same thing. So here first you see starts from 0, it's a sine. You see the minimum value, -2. And the period is 2 pi over omega. It is equal to 4, right? Based on the graph, 2 pi over omega is equal to 4. So omega is 2 pi over 4 is pi over 2. Okay, so that's it. This is the answer, the one possible equation for this graph. Okay, so you should do more exercise, and then we will get a better feeling about it. Okay, so in the book there's exercise 21 through 30. There's many practice. You can check them and see if you get the idea. Okay, so for example, let's do some examples. For example, when we have this. So -2, -2, the period is 4. Okay, the period is still 4. Okay, you see this part, it starts from a number, it's cosine. It starts from -2, so the coefficient is -2. And the period is 4. So omega is 2 pi over 4 is pi half. Okay, you see the order. So first you determine is this cosine or sine. It does not start from 0, so it's cosine. The first number you see is -2, so it's -2 cosine. And the period is 4. So 2 pi over omega is 4, then omega is 2 pi over 4, it's pi half. So it's pi half times x. Okay, so today we stop here. We finish the section about the graph of sine and cosine. And you do exercise, make sure you understand this section. This section does not contain a lot of formula, but it gives you the idea about the graph of sine and cosine, and you should be able to graph some functions, and you also you should be able to write the equation for certain graphs. Be careful about the amplitude and the period. That's it. Okay. Thank you very much. We'll stop today.